Alright guys, 7-8, graphing square root and other radical functions. Due to our snow days, we are only going to focus on examples 1, 2, and 3. Um, Not that examples 4, 5, and 6 aren't valid and good math stuff, but it is not on your test, and therefore I think in your best interest, we're just going to clip it down to there so that you can focus on those particular concepts. All right, I am going to skim over this next page. Just going to tell you, you should look in the book and look over this. It does give a really good description of what everything is, but it is in math geek terms, so just so you know. All right, this is the summary box, and just like the absolute value and the square, the quadratic functions, we also have parent functions here. So y equals the square root of x is the parent function. The reflection, you have the negative outside. And then a horizontal is when you have it inside, so the right and left is just like it was with the absolute value in the quadratic. It is inside underneath the radical, and the it's going to be the opposite sign just like the other ones. And then your vertical, the up and down movement, is going to be outside of the radical. Okay, so now with that, let's go forward. Translating square root functions vertically, this is up and down. If we have a number outside of that radical, that is how far we shifted up or down. So this says plus 2, so we go up 2 units from the origin, and voila. Minus 1, we go down 1, and then we sketch that square root of x. This is what the square root of x looks like, by the way. It is only the top part of the rotated quadratic function, if you will. It's just that top half. All right, so going down here, graph y equals absolute value of x plus 5, and y equals the absolute value of x minus 7. So if we just do a simple sketch, plus 5, so 1, 2, 3, 4, 5. Put your origin, I'm sorry, not your origin, put your vertex there, and then you just, and there you go. You have to do the sound effects too. Just kidding. All right, now we have the square root of x minus 7. Oop, we're going to go a little bit higher. So we got 1, 2, 3, 4, 5, 6, 7. So I'm going to put my point here, the vertex there, and then sketch like that. That is it. So this one we went down 7, and this one we went up 5, right? Up 5, and then the down 7. All right, let's go ahead and move on to the horizontal movements. Translating square root functions horizontally. So now, whoops, not what I wanted to do. There we go. All right, just like before. Okay, so we have this plus 3 inside of the radical. So this means instead of going to the right 3, we are going to go left 3. And this says minus 2. Our instinct is to go to the left. This one we actually go right 2. Okay, so just like the earlier functions. And hopefully you remember that. And I know it was tough, but because it's consistent through everything, hopefully that makes it a bit easier. Okay, so let's take a look at this one. Oop, not that high. So we want to graph y equals x plus 7. So because it has that plus there, our instinct is to go here, but remember then that means we go left 7. So 1, 2, 3, 4, 5, 6, 7. And then we put our point there, and here you go. The next one we have is y equals the square root of x minus 5. So we want to go left, but it's right 5. So sketching this one, we put our point here and we graph. And that's it. Okay, not too bad. Whoop, not what I wanted. Can't find my mouse. There we go. All right, now graphing square root functions. Taking a look at the textbook example. All right, now we have added a little bit of fun with respect to this right here, right? This little guy here. We've incorporated something new. So we have to take that into consideration. The graph of y equals negative 2 square root of x is a stretch of y equals square root of x by a factor of 2 and a reflection across the x-axis. So they sketched that. That's what they have here, okay? And then this told them to go 1 unit to the left. So they went 1 unit to the left. Oops, didn't want to move the thing. They went 1 unit to the left, and then negative 3 tells them to go down 3. And that's where that comes into play. If you are not comfortable, if you don't remember how to do some of these things, if nothing else, when you get your equation here, you know that this is telling you that you're going to go left 2, and this tells you you're going down 1. So you know that is where the vertex of your radical function is. So let's go ahead and, wow, that was bad. We go 1, 2, down 1. So we know we're starting here. Okay. Worst case scenario, you always, always, always have your t-chart. Always. Put in an x, plug it in just to see what you get. So put in 0, put in 2, put in negative 1 if you wanted to. I'm going to do 0, 2, and 4. Okay, so putting 0 into this equation, and I am going to go ahead and write it out longhand, even though most of you don't need it. We have 0 plus 2 minus 1. Okay, so 0 plus 2 is just 2. 3 times the square root of 2 minus 1. Now, I do not know that off the top of my head, so I'm going to use the calculator. 3 times the square root of 2, close parentheses, minus 1 is 3.24. Okay, so 3.24 is what I get up here. All right, now doing 2, we have 3 times the square root of 2 plus 2. I'm just substituting in that 2 for the x, and then minus 1. 2 plus 2 is 4. The square root of 4 is 2. I know that one. So 2 times 3 is 6. 6 minus 1 is 5. And then 4. 4 plus 2. Sorry. So we're going to have 3 times the square root of 4 plus 2 minus 1 equals something. Now, I could have been a little bit better and picked numbers that would give me perfect squares underneath here, just like this 2 was, but that's not always going to happen. So just use the calculator to help you out with this part of it, and it's not a big deal. We have 3 times the square root of 4 plus 2 is 6. Close the parentheses, minus 1. You want to do as much simplifying in your head as you can, because that's where some of the mistakes come into play with respect to the calculator. All right, so there we have 6.348, so that's 6.35. All right, so 6.35. Now, I know these numbers are a little bit crazy, so we're just going to do approximations. We're not going to be exact sciences here. Exact scientists. Alrighty. So, my first point, 0, 3.24. Hopefully you're understanding why I just laughed. I went out on the X's. 3, 4, 5, 6, 7. Duh. All right, and then 2, 5 is here, and 4, 6.35 is somewhere in this general neighborhood. So we're going to have a function that looks similar, and you do want to have your curvature there. Eee! um, well, heaven's sakes, why did I go way up there? Lord help me. I am so sorry. All right, ignore that part. Let's just regraph those. All right, so 2 we have at 5, 3, 4, 5. And 4 we have at 6. 6.35 is right there. Heavens to Betsy. All right, there you go. There is your graph. Um, hopefully I haven't lost you too much. Apologize about that. I am human though, and it's good to see that your teachers make mistakes as well. Hopefully this is easy. You don't have any problems with this. If you do have questions, please let me know. You know where to find me.